All right, ladies and gentlemen, this is going to be a continuation of section 6.6 when we're talking about right triangle trigonometry. Well, this is going to be your favorite part of right triangle trigonometry, which we'll call applications. Code word, word problems. It's not as bad as you think it is, okay? So we already remember sine, cosine, and tangent. But really what this angle stuff is used for is to measure stuff we normally would not be able to measure. Okay, so let's say we had said person. Let's call her Kennedy. And then Kennedy always is noticing stuff and looking up. So she says, she gets hired by a city to measure this building. That's a pretty big building, right? So she's not going to sit here and try to get a measuring tape and say, okay, how long is this? That'll be a damn disaster. What would she do instead is she'd measure the distance from here to here, because she'll be a great engineer one day, right? And then she says, okay, well, I still don't know. And then let's say this distance is 100. Then she would say, okay, well, let me see about this building here in 100 feet, per se. Okay, now we're trying to figure out the height of the building. Okay, well, this is what we like to call the line of sight is used for. And you'll see this all the time. Contractors will be on a tripod looking at a distance and trying to figure out what the angle of incline or angle of decline is. Because if I know this is 60 degrees, I have the ability to calculate the side, since this is obviously going to be a right triangle. Okay, so you'll know this. Now think to yourself this. So I need you to think, what trig function do you know? Okay, which one do you know that involves this side, this angle, the adjacent side, and the opposite side? Obviously, that should be jumping out at you by now. It is your tangent, correct? So the tangent of the angle, which was 60 degrees, has to equal the opposite side, which is x, over the adjacent side, which was 100 feet. So this means that if we solve for x, x is 100 tangent of 60. Now note, we don't always know the definite answer. And guys, we're limited to just angles that are acute. So what do I mean by acute? This angle, if it's 30, if it's 60, if it's 45, we can figure this out. And even I'll teach you some ways of figuring out 15s and some other cool stuff when we have the sum and addition formulas. But right now, no, acute angles are what we're going to do. But if this angle is like 39.5, you'd need calculus 2 to actually figure it out using Taylor expansions, which you won't get to until later on. You'll truly see what a sine and a cosine really is. Okay, but we can calculate this. Why so? Well, I need some space. I'm going to erase this off. This is the height of this building right here. Okay, so I'm going to erase this, and this is our answer: 100 tangent of 60 degrees. Well, hopefully we're good at calculating degrees to radians by now, okay? But some people are good enough to already know it at 60 degrees. That means we're talking, that tangent's going to be square root of 3. And if you're that good, you're right where you need to be at. But if not, then you got to find some way of figuring out this tangent of 60 degrees. So if you think unit circle, here to here is 90. So that means 60 needs to be somewhere in here. So here's my unit circle. This is our 60. Well, what is that point exactly? Well, I really don't know. But if you put that 30, 60, 90 triangle in there like I did before, okay, you'll see that this is going to be 1/2 root 3 over 2. Okay, that's one way. Or you can go through the work and transform 60 degrees into radians. So that means you need to multiply by 180 degrees over pi radians. That's the conversion factor. Either this or it's reciprocal. Remember, and we talked about this is just one. So we're not changing the value, we're just turning it into a different measure. But the reason why this is the ratio we want is because the degrees will drop. It leaves you 60 pi over 180 radians. And this simplifies to pi over 3 radians. Now that should be very familiar to a lot of you. So 100 tangent of pi over 3 is an equivalent way of looking at this. So, do we know what that is? I absolutely think we know what that is. Okay, so this is exactly where it is. So tangent is the y over the x, which is going to end up being 100 square root of 3, which on WebAssign is going to tell you to approximate this using a calculator up to a couple digits. So you're going to need a calculator for this, okay, if you're doing it on WebAssign. And I think this is 1.73 if I remember correctly, which this is equal to is equal to 173 feet. So that building is 173 feet tall. To give you an idea, one story is 10 feet. So this is 17 stories tall. It's a pretty tall building, okay? No possible way of measuring it, but using a little bit of right triangle trigonometry, we actually could figure it out. Okay? So that's pretty much what it's used for. Let's take a good look at something a little nicer, okay? And I'm going to draw you a little diagram to give you a little bit of extra basis. Okay, so let me go ahead and clean my board a little bit. So let's say this is you, and this is your eyeballs, and you're looking, and this is your face. This is you looking at a flat line of sight. Okay? This is what you would do if you normally look forward. This is your eye level. Okay? Now, if you look up, so let's say you looked up this way. This is you looking up. Okay? This is called the angle of elevation. Okay? And if you look down from the eye level, this is called the angle of depression. Okay? Oop, can't spell too well on this thing. Okay? But this is how pretty much how it works. So when you use sight, you actually can determine distance of a lot of different things. Okay. Now I have a really good example here I want to do with you guys. It's a bit of writing, but I'd rather talk it out with you, or maybe I can pull one right off a website. Hold on a second. Let's see here. All right. So it says the angle of elevation to the top of a very tall building is found to be 10 degrees from the ground at a distance 1 mile from the base of the building. Use information to find the height of the building. So first things first is you're going to have to draw a picture. You can't do this without drawing a picture. So let's see if I can do this without blowing the problem here. Alright, so it says that the angle of elevation. So what's the angle of elevation to the top of a very tall building is found to be 10 degrees from the ground. So here's the ground. Here's a very tall building. Let's help them. Very tall. Oops. Move this out the way for you guys. That's a terrible looking building. Here's my building. And they said the angle of elevation from this ground level is found to be 10 degrees. So this is 10 degrees. Elevation. Alright. Now what did else they tell us? From the ground at a distance of 1 mile from the base of the building. So this point right here to right here is 1 mile, which is pretty reasonable. Pretty reasonable. Okay. Then it says, using this information, find the height of the building. So we got to find this. So this is exactly like the guy we just did. Okay. So what involves, so this angle we know, what involves the opposite side and the adjacent side? Yes, you're correct, tangent. And you'll notice tangent is a big theme of this, because often when we have line of sight, we don't know how long this is, this hypotenuse is. So tangent is literally the guy you're going to use a whole lot of. X over 1, so that is just going to be tangent. So x is just tangent of 10, and you got to plug this into a calculator, which I'll let you do, to approximate and stick it in WebAssign. That's pretty easy. Let's do one more that's got some meat and potatoes to it. Perfect. Didn't even give you a diagram, man. This place is nice. All right. So it says a water tower is located x equals 400 feet from the building. Okay, so see the building, you see the diagram. You got your water tower. From a window in the building, an observer observes that the angle of elevation, so that's at 39 degrees there. So he's looking out the window, right, and he's looking up at an angle of depression of 25. It says, how tall is the tower? So this is going to be a fun one. Here we go, and we'll see if we could do this in the time that's left. I'll let you figure it out. Window is here. Looking down is here. This is the total height. Okay, this is 25 degrees. This is 39 degrees. Okay, we know here is 400 degrees. We know that we need to find this, but also that we need to find this. Why? Because it says how tall is the tower. So we need to figure out the tower is from here to here. So we need to figure out what x is, what y is, add them together, and we're good to go. Now I'll let you put that together and see how that is. And if